Okay, final exam review. What are the names of the three collinear points? Well, there's these 3 points that go in the straight line, so it'd be LJK. So it's letter B. Letter T is a midpoint of SU. What are ST, TU, and SU? So we know if that's a midpoint, then 9x and 5x plus 28 have to be equal. So I minus 5x, so 4 times x equals 28. X is 7. Then what I did is I put 7 in for x, and 9 times 7 is 63. Then 5 times 7 is 35, plus 28 is 63, so it'd be 63, letter D. Okay, Noam walks from school by walking 8 blocks north and 6 blocks east. How much shorter would his walk be if there were a direct path from the school to his house? Assume the blocks are square. So here he starts from his house. He goes 8 north and 6, and he reaches his destination. So he's walked 14 blocks. Okay, then what I need to do is find out if he just walked from here to here, how long would it be? So I need to use my a squared plus b squared equals c squared, the Pythagorean theorem. So a can be 8, c can be, or b can be 6, and then c is unknown. So a to the second is 64. Then 6 to the second is 36. So I add those, I get 100, c squared. 64, 36, so 100 is going to equal c to the second, and then I find the square root to get rid of the second power. That's 10. The square root of 100 is 10. So if he just goes from here straight here, that's 10 blocks. So the question's asking me, how much shorter is it going to be? Well, if it takes 14 that way and here it only takes 10, it's going to be 4 blocks, so C. Okay, number 5. Of all rectangles that have a given area, so let's give it an area of like 18. Is there one with the greatest perimeter explained? So 18 could be a 2 by 9. It could also be a 3 by 6. So that'd be 2 and 9. 9 plus 2 plus 9 plus 2 gives me my perimeter of 22. 3 plus 6 plus 3 plus 6 gives me an area of 18. Now the reason that this is a larger area is because it had the longest dimension of all of them, 9. 6 and 3, 2 and 9. 9's the largest dimension. So it's yes, the one with the longest dimension has the greatest perimeter. Number 6. Write this statement as conditional if-then form. All triangles have 3 sides. All triangles have 3 sides, and all triangles have 3 sides. That's complete nonsense. If a figure has 3 sides, it's not a triangle. Obvious nonsense. If a figure is a triangle, all triangles have 3 sides. Well, nonsense. If a figure is a triangle, then it has 3 sides. So that's got to be D. Okay, which statements provides a counterexample to the following faulty definition? A square is a figure with 4 congruent sides. Well, again, we talked about that a 6-sided figure, like that's a hexagon, these could be congruent, but these might not be, so that's not a square. So it's a 6-sided figure can have 4 congruent sides. Okay, what's the value of x? Again, you just go 8x minus 8 equals 7x plus 8, so I minus 7x minus 7x. 1x minus 8 equals 8, and then plus 8. Plus 8, 1x equals 16, which means you have 16. Okay, corresponding angles. First off, let's know what corresponding angles are. I take one of them inside, and its corresponding angle would be 2. 11 and 3. 13 and 5 are corresponding. 16 and 8 are corresponding. And also, I mean 12 and 4, 15 and 7. You notice a pattern here, 14 and 6, 9 and 1. So 7 and 3, no, those are vertical, not corresponding. 8 and 3, no, those are supplementary. 3 and 11, yeah, 3's corresponding angle would be 11, so it's letter C. Okay, which statement is true? Again, my pen kind of screwed that up. I'm going to rewrite it. Okay, so FEG and CBA are alternate angles. So what is an alternate angle? Okay, an alternate angle would be like here and here, both in the interior, and then here and here, just a diagonal from each other. So FEG's here. Well, that's not even an interior angle, so it can't be that. Forget that. CBE and DEB are alternate angles, so CBE and DEB. No, those are on the same side, so they can't be. They're in the interior, but they're same side. CBE and DEB. So CBE right there again. And DEB. Okay. Yeah, it's those two. They're on the same side, and they're on the interior, so that's got to be D. Okay, let's explain what's going on here. The relationship all the angles have. Here's my interior. Those are alternate interior. Those are same side interior. And anything outside, like 8 would correspond to 4, 7, and 3. It wants to know 8 and 4's relationship, so 4 and 8, so it's corresponding angles. Okay, RS is parallel, and B and H are supplementary, meaning they add up to 180. Okay, so again, R and S are parallel, B and H are supplementary, so that's what I need to prove. So go through there. R is perpendicular to S, that's given. B and C are vertical angles, making them congruent. C and E are supplementary, yeah, because anytime I have same side interior, they add up to 180, okay? So same side interior equals 180 degrees, okay? Then E is congruent to H from vertical angles, so everything's good so far. So B and H are supplementary by substitution, okay? So let's rewind here. B and C congruent. And we said C and E were supplementary, yep. And E and H are congruent. Well, if C is supplementary to E and H and E are the same angle, okay? Because B equals C and those two are supplementary, E equals H, well, B and H are supplementary given substitution, okay? Because those are equal, and those are equal, and those are supplementary, so then B is going to have to be supplementary to H at the end. Basically, you go through a proof, and if there's a statement that's just complete gibberish, okay? Like, for example, B and H are corresponding, okay? But that doesn't make them supplementary because you're not trying to prove that C and H are supplementary. You're trying to prove B and H. So again, R and S parallel, B and C congruent, D and H supplementary. Well, that's wrong because H is not an interior angle. That's complete bogus. Okay. All right, find the measure of angle P. They give you this, so P was right here. Alternate interior angles are 106, they're equal. And then these two have to add up to 180, so 180 minus 106 was 74, so it's B. Okay, which lines are parallel if measure of angle 1 plus measure of angle 2 equals 180? So here's 1 and 2. Now you want to cross out the line that has nothing to do with 1 and 2. That's this one. So any answer with G and H needs to be eliminated. It's J and K you got to look at. And what are those? Well, they're not alternate. They're same side. So that's A. Find the value of X. You know that's 110. That's 110. And then you lose your rule of 180. 180 minus 110 minus 57. That was 13. Okay, given that these triangles are congruent and B and Q are corresponding, they would have to be equal. So 3V plus 4 equals 8V minus 6. So minus 3V minus 3V. So 5V minus 6, 4 plus 6 plus 6. So 10 equals 5 times V. V is 2. So I take 3 times 2 is 6 plus 4 is 10. Okay, and the other one's 10 as well. Okay, RS and UT, we marked those as congruent. We also marked RT and US as congruent with double. And then they also have a common side. So that's 3 sides. So that's the SSS postulate. And STTS, that's the reflexive property. Okay, which pair of triangles is congruent by ASA? That's ASA. But that's AAS, so it doesn't work. That's SAS. That's SAS. SAS. Got to be ASA. So ASA, ASA. D. Okay. Supply the missing reasons to complete the proof. So they told us that Q and T are congruent. They also told me QR and TR were equal. And then we didn't have a common side, but we had these vertical angles here. Those are congruent, so it's ASA. That's what proves the triangles are congruent, and then we use the corresponding parts. Okay, for what situation can we prove the two triangles equal using the hypotenuse leg theorem? Okay, again, here the hypotenuses were not congruent. I mean, they share a common side, but that's just a side and angle. Makes no difference. That one doesn't work. Now, here, those two angles are congruent, and then the triangles are congruent by the SAS postulate, okay? So that means the sides are congruent, and that's the HL theorem. Hypotenuses are. Then here they share a common side. So we have the hypotenuses that are congruent, and then one other side's congruent. So that's your hypotenuse leg theorem. And I know it's SSA, but if it's a hypotenuse that's one of the sides, then the AS thing does work, as long as it's right angle with the hypotenuse. So it's 2 and 3. Common angle, which letter's common? Be C. Okay. And you can kind of tell C is inside both the triangles. Okay, DE is the bisector of JL. So bisector means they form right angles all the way around. Okay, and those are congruent. Then I made a triangle, and they shared a side, so those are congruent. And then by the SAS postulate, okay, the triangles are congruent. So DJ and DL are also congruent. So that would not be the answer because that is true. K is a midpoint. Yeah, that's true. Yeah, they're perpendicular. It said it was the bisector because it says DK and KE. Well, I don't know anything about KE. Okay, so it's got to be that one. And then the smallest angle of triangle ABC. So what's your smallest side? It's 9. It's opposite that angle, so it would be letter B. Okay, I'll do my best to do the other one.